When you graph trig functions, your calculator must be in radian mode. What is this? What is the meaning of this graph? What does that say? 7?
I think it's a 1.
It's a 1? No, it doesn't. Anyway, PCH, what do we got tomorrow? Tomorrow, speed quiz. Tomorrow and Friday. And don't forget we got a regular quiz on Friday. And AB, we have a test tomorrow. Okay, if you think we're going to do them all, you got another thing coming, Buster. You got to revise that. Yeah. Are you guys checking it on your graphic calculator? That's because you're not in radian mode. What kind of person, okay, first of all, just tell me this. What kind of person would need a calculator in degree mode? That says a lot about a person. The person that takes physics. Here, I'll tell you what to do. You keep your calculator in radian mode, and then when you do physics, you use the degree sign to override the radian mode. So like if you want to compute like the tangent of 37 degrees, then you put the degree sign there. So even if you're in radian mode, it does degrees. You know what I'm talking about? Where's the degree sign? Well, if you don't know, in the catalog, but well, for TI, it's in the angle menu. For the other people, the prism people, where is it? Otherwise, you got to keep switching back and forth. PCH, physics. Calculus, physics. Anytime you do math, you should be in radian mode. Okay, you got to tell me the real place to start. Look, number 1, you got absolute value on the whole thing. That means everything below the x-axis gets reflected above, right? Okay, no. You want to do them all complete thing? Are you serious? Okay, number 2, you got the absolute value on the x. What does that mean? Erase everything to the left of the y-axis, keep and reflect the remaining portion. So that means it's going to look like this. Sine looks like that, right? Erase everything to the left of the y-axis, keep and reflect the remaining portion. It's going to look like that. It's going to look like a mustache. Okay, the problems only start getting difficult when you hit number 8. All the rest is you just take the base graph and you do stuff to it. Okay, I'll do like one of them. Which one you want to do? Like 3, 4, 5, 6, 7. Pick one. You write 1 through 11 and then now you're afraid to say 3, 4, 5, 6, or 7. 3! Wrong! -2 cosine pi. Remember, do all the stretching and shrinking first, right? Okay, now don't worry about the range yet. Okay, what you should do is graph one period and then you copy and paste as needed. Okay, one period of cosine looks like this. 2 pi, 1, -1. Right? What does this do to the graph? It multiplies the x coordinates by 1 over pi. So if I multiply this by 1 over pi, this becomes 2. What does this do? It multiplies the y coordinates by 2. And then you got to reflect it over the x-axis. So then now you got this. And then now what does the x plus 1 do? That shifts it 1 to the left. So everything goes 1 to the left. So this point goes here. This point goes there. This point goes there. That point goes there. Am I looking at the right graph? Am I looking at the wrong graph? I'm looking at the right graph. Yeah, that's what I told you guys. Because this is 1. So 1 is actually 2 hash marks, fool. So this point goes here. Oh, now you guys want to chime in. Now you guys know how to do it. So this point moves here. So here, basically you got this then. And then, where do we graph it? It says from -2 to 2. So all you have to do is just go hug up. Oh, that doesn't look good. Hug up. So, there you go. So just graph one period first, and then you just copy and paste as needed. Yeah, you want to do another one just for funsies? Okay, which one? Number 5. That's the easiest one in the whole sheet. Okay. Y equal cotangent pi x over 3. Okay, what does one period of cotangent look like? Wooga! Pi. Right? What does this do to the graph? It multiplies the x coordinates by 3 over pi. So if I multiply this by 3 over pi, it becomes 3. And that's it. You just have to do one thing. And then now you just graph it, what does it say? From 0 to 6. So copy, Control C, and paste, Control V. Okay, now, what about 8, 9, 10, 11? Do them all. Okay, number 8. Y equal cosine squared. Now, you guys know from last year that cosine squared x means cosine x quantity squared, right? That's the way you gotta punch it in your calculator. You know? If you put the square over there, your calculator probably doesn't understand what's going on. So when you punch it in your calculator, you gotta go y1 equal cosine x squared. Because that's what it means. It doesn't mean cos squared times x now. That'll be just ludicrous. Okay, so what's your base graph? Your base graph is cosine, so 1, 2, 3, 4. Woo! 1, -1. So cosine looks like this. Yeah, that's better. So all you have to do is square every y coordinate on this graph. Every y coordinate gets squared. Okay, so here, what's the y coordinate here? 1. What's 1 squared?
1.
0 squared. -1 squared.
1.
0 squared.
0.
1 squared. So basically, what's going to happen? All the negative values when you square it become positive, so there's not going to be any graph below that x-axis, right? So it's going to look like this. So basically, what you're getting another cosine function, except the amplitude is smaller now, yeah? And you guys know what I mean when I say amplitude, yeah? Because the original function, the amplitude was 1, now the amplitude is what? See, now it's just oscillating about the line y equal half. The amplitude is half now. Yeah, so that's why we did all these, remember when we studied functions? Of course not. Remember I gave you guys a graph, and then I asked you to graph y equal f squared? Is that so now you can do this? F squared just means you just square every y coordinate on the graph, and that's what we just did. So obviously we did the problem for nothing. Okay, next, number 9. Y equal cosine x plus sine x. Do we know how to graph cosine? Do we know how to graph sine?
Yes.
Do we know how to add? That's kind of shaky. That's all you gotta do is add them. Anyway, if you don't know anything, if you just absolutely know nothing, what can you always do? Plot points. If you don't know anything, plot points. Okay, here's the okay, just like when we did, remember we did functions, I gave you the graph of y is equal to f of x, y equal g of x, and then I asked you to graph y equal f plus g of x. Remember that? And so you can do this right now, right at this minute. Because some of you are just looking at this problem for the first time. Feeling guilty, huh? Okay, here's cosine x. Here's sine x. Just add the two graphs together. So, look at the y coordinates. What's 0 plus 1?
1.
What's 0 plus 1? 0 plus -1. 0 plus -1. 0 plus 1. And then if you want to go in between, like here, pi over 4, both y coordinates are both the same, right? Root 2 over 2. So what's root 2 over 2 plus root 2 over 2? root 2, which is about 1.4. So or just go like this. Double your pleasure. Ooh. Like that. And then over here, look, this y coordinate is positive, this coordinate negative, and they're the same length, so they're going to cancel out to 0. And then over here, you get two negative things, so double your pleasure. And then over here, one is positive, one is negative, they cancel out to 0. This is just to get more points, yeah? And then connect the dots, but please don't connect the dots with a straight line. So what happens when I add a cosine and a sine graph together? What happened? This is just one period, and of course it's going to start again, right? What happened when I graph the sum of a cosine and a sine graph? What happened? You get another cosine graph or a sine graph. Come on, didn't you guys learn this in physics? Sound waves. What's that? Anyway, when you add a cosine and a sine graph together with the same period, what happens is you get another cosine or sine graph, except the amplitude got bigger. In fact, did it double? Here's a question for you. So the amplitude of cosine is 1, the amplitude of sine is 1. So I add them together, the amplitude is 2. No, moose breath, it's not 2. 2 is up here. The amplitude is that. What is that? It's root 2. Whoa. Could that be something that's going to be in the next test? Yes, but we're going to learn how to handle this later. Yes, if you add a sine and a cosine function together with the same period, you will get another sine or cosine function. And you're going to have to change it into another sine or cosine function too. But we have to learn about identities for that to happen. That was a waste of time. Anyway, if you don't know anything, just plot points, right? How many people just plotted points? That's what your graphing calculator does, except it does it every like 7.5 degrees, which is pi over 24. So basically your calculator just plots a point every pi over 24 and then draws the picture. Okay, now number 10. Okay, here we go. I think we'll be seeing something like this on the next. Okay, 0 to 4 pi. What is the... Okay, now I want you to look at the graph of sine. Sine looks like this. Right? What's the biggest and the smallest value sine can ever be? 1 and negative 1. We learned that last year, right? It just oscillates between the two. Okay? So watch this. Since the biggest sine ever gets is 1 and the smallest it ever gets is negative 1, all you do is this. Multiply 1 times x. What do you get? X. Okay, thank you. So here. So what you do is you draw the line y equal x up here. Okay, and the smallest it ever gets is negative 1. So negative 1 times x is negative x. So graph y equal negative x over here. And then you know how a sine graph works, right? It starts at 0. Hits the maximum, then it goes to 0, then it hits the minimum, and then it goes to 0, right? 0, maximum, 0, minimum, 0. That's how sine goes, right? It just keeps oscillating. And then 0, maximum, 0, minimum, 0. And then you just connect the dots. Woohoo! Woohoo! Yippee! See, like this over here, if you just had regular sine x, what happens is the graph just stays between y equal 1 and y equal negative 1, right? It just oscillates, right? 0, max, 0, minimum, 0. But now, since you have an x in the front, then what happens is the amplitude changes as it goes. It gets bigger as the graph goes out to the right. Whereas in this one, the amplitude just stays constant at 1. You know what I'm talking about? So you can do this with any graph. I can put any function over here, like in number 11. Okay? Okay, the only thing I did is I changed that to 2x. So what does that mean? Instead of this being 2 pi, what's going to happen? What does this do to the graph? It multiplies the x coordinates by 1/2. So this is actually pi here. Okay, and 2, 3, 5. Basically, it shrinks it by a factor of 2, right? Okay, so since the biggest sine ever gets is 1, what is 1 times e to the negative x? E to the negative x. Do we know how to graph y equal e to the negative x? Yes, we just did the last chapter, right? It looks like this. Right? It's the graph of e to the x reflected over the y-axis. We just did that, right? And since the smallest sign ever gets is negative 1, what's negative 1 times this? Negative e to the negative x, which looks like this. And then the graph of sine is just going to oscillate between those, just like over here. You graph y equal x, y equal negative x. Y equal e to the negative x, negative e to the negative x. So it doesn't matter what function I put here. I can put gorilla. All you have to do is graph gorilla and negative gorilla, and then the graph is just going to oscillate between the two. So same thing here. Sine, how does sine work? 0, max, 0, min, 0. Max, 0, min, 0. So it's just going to go like this. And then it's just going to keep on going. What's going to happen? Keep oscillating, but then the amplitude gets smaller and smaller, right? What do we call that in physics? In fact, you can impress your physics teacher when you get there. What is this called when the amplitude gets smaller? What's the word? Chai. Doesn't matter what the word is. Damping. Who's in physics? Quinto. Damping. Have you heard that word before? Okay, so that takes care of the graphs. Here's an example of damping. Look. See this? Look at this thing. Go. Slow down. Damping. Okay, whatever. You'll learn that in physics. Okay, 12, 13, 14, 15 are all the same problem except different. So which one do you want to do? Well, obviously 14. Well, let me ask you this. How can you do 12, 13, 14, and 15 but not 14? That's what I want to know. That's the bigger question. Okay, obviously this is period 3, so you're not going to answer me, so let's just do it. F of x is equal to x squared times tan x. Okay, now, how do you determine if a function is odd, even, or neither? You plug in negative x for x, and if it comes out to the original function, it's even. If it's the opposite of the original function, if it's odd, and if it's neither, it's neither, right? So what you got to do is plug in negative x for x, but probably what you want to do is change tangent to sine over cosine. Did you guys do that? Okay, f of negative x is equal to negative x squared. So plug in negative x wherever you see x. And simplify it. Okay, what is negative x quantity squared? What is sine of negative x? Negative sine x. How do we know that? It's in the notes. That's an identity you need to know, people. Here, let me write it out for you. Sine of negative x is equal to negative sine x. How are we supposed to know that, Mr. Park? Because sine is an odd function. F of how do I know sine is an odd function? Well, here, let's look at the graph. Whoa! Whoa! Isn't the graph of sine symmetric about the origin? Yeah, that's why it's odd. And then cosine of negative x is equal to cosine x. How am I supposed to know that? It's in the notes. Plus, not only that, if you graph cosine here, ooh, isn't it symmetric about the y-axis? That means it's even then, right? So f of negative x equals f of x. See, that's why, if you guys try to memorize all these little tidbits here and there, and then that's why you guys have a hard time. If you see how it all fits together, then isn't that easier to learn? I like memorizing little tidbits. Okay, so what is cosine of negative x equal to? Cosine x. Is this equal to the original function? Is it the opposite of the original function? Height, which means yes. So it's odd. This is That's how you determine if a function is odd or even. In fact, now we know what is tan of negative x then? Negative tangent x. How come? Because, well, you could change it to sine over cosine, or just look at the graph of tangent. Look at it. Here's negative pi over 2. Well, this is just one period, but it's going to be the same thing. Here's the graph of tangent. Is that symmetric about the origin? Yep. So tangent is an odd function, which means tan of negative x equals negative tan. This is a super important thing, you know. These are called the odd even identities. I'm sure you learned them last year, right? You know what? In fact, why don't we talk about this since today is basic? Can somebody else tell me, besides the graph being symmetric about the y-axis, why is cosine of negative x equal to cosine x? Here, I'll draw you a picture. Here's the unit circle. Here's angle x. Here's the angle negative x. If this is the angle x right here, what are the coordinates at this point? What did we learn yesterday? Cosine is the x coordinate, sine is the y coordinate, right? Okay, here's the angle negative x. What are the coordinates at this point? Cosine of negative x, sine of negative x. Now look at the symmetry of this graph. True or false? The x coordinate of this point is equal to the x coordinate of that point. True, because you got to go the same distance to the right, right? So that means this equals that. These two are equal. Cosine negative x equals cosine x. True or false? The y coordinate of this point equals the y coordinate of that point. False. No, how can a positive number equal a negative number? However, they both are the same length, but they're opposite in sign. So that's why sine of negative x is equal to negative sine x. So that's another way of looking at it. I'm glad I brought that up. That went over well. Okay, so no other questions? Everybody can do 16 through 19. You're supposed to look at the graph and then remember how you asymptotic behavior limit. So in other words, you got to know what the graph looks like for 16 through 19. These are all base graph. So on Friday's quiz, I would guess the first 4 problems are you're going to graph. You're going to take sine, cosine, tangent, secant, cosecant, and you got to do stuff to it. Okay, move on. So what are we doing today? We're doing trig A2. Oh, we got to know identities, and then we got to know how to do proofs. And then we've got to be able to solve equations. And that's probably, I guess if you had to boil it down, that would be the most important thing in this chapter. How do we solve equations? Okay, but before we get there, for trig A, what are all the identities you have to know? Because trig B, that's when you're going to have to know the sum and difference identities, double angle, half angle, and even the triple and fourple angle identities. Okay, since we're honors. Yeah. Okay, but in trig A, you just have to know the basic identities. Like, what's the one identity your teacher told you last year you better remember? Cosine squared x plus sine squared x equals 1. Right? If there's just one identity you remember from trigonometry, that's it. You take the ACT test, you better know that one. Okay, and let me show you something. Why did your teacher explain to you why cosine squared x plus sine squared x equals 1? Here, I'll show you right here. Here's the unit circle. Wow! Here's angle x. What are the coordinates at this point? Cosine x, sine x. Remember, cosine is the x and sine is the y. So if I draw a right triangle here, what's this length here? Cosine x. What's that length? Sine x. And since this is the unit circle, the radius is 1. So somebody tell me, why is cosine squared x plus sine squared x equal to 1? Duh. The answer is duh. Pythagorean theorem, right? This squared plus that squared equals that squared. And remember, cosine x squared, that's just the way we write it, right? Cosine x squared, we don't write it like that. We write it like this. You just have to get used to that. That's just mathematical notation. I'm not sure why. I guess that makes it shorter to write. I don't make up this stuff, okay? I'm just translating the information to you. Okay, so that's why we call this the Pythagorean identity. Pythagorean identity. However, there's 3 others. So the Pythagorean identities. Now I'm sure you learned the other 2, right? Now to derive the other 2, all you have to do is do division. Okay, take this equation, divide both sides by cosine squared x. Okay, divide that by cosine squared x. Divide that by cosine squared x. Divide that by cosine squared x. And there you go, that's the second Pythagorean identity. Okay, take this original one, divide both sides by sine squared x. Divide that by sine squared x. I don't know cotangent yet. Divide that by sine squared x. Divide that by sine squared x. And voila! We have the three Pythagorean identities right there for your viewing pleasure. Now, you can't just memorize it in this form now. Like I said, you gotta be able to work with it both ways, and you gotta be able to lomi it too. For example, what if I give you this? What if you're doing a problem and you see this? Secant squared x minus tangent squared x. You should be going, hey, you somebody, yeah? Look at the second one. Hey, you somebody, yeah? Yeah, what is this? That's 1. Just take this and move it on that side. It's called lomi. We already know how to lomi. We know how to massage. Okay, what about this? Cotangent squared x minus cosecant squared x. What is that equal to? Hey, you somebody, huh? Okay, I'll give you a hint. Look at this one. Just like move the equation around. Massage it! -1. How come only one person got it? Well, you guys think you're better than me now, huh? Okay. So what about this? What about sine squared x minus 1? Give me a hint. Look at the first one. Hey, you somebody, huh? Negative cosine squared x. So you cannot just memorize the identity in the form it's given. You got to be able to massage it. But you got to be careful now, because every year students, they do crazy things. Like, what if I did this? Secant squared x plus tangent squared x. Hey, you somebody, huh? No, that's nobody. That's nobody. Okay? No, because every year, I'm serious. They go, oh, you somebody, you won. No, you're not one. That's a fatal, that's what we call a fatal error. Okay? So these are the only identities, well, of course, the odd and even identities, right? These are the ones, oh, and the cofunction identities. Because this is going to be on next Tuesday's speed quiz. No, not yet. What are the cofunction identities? Cosine pi over 2 minus x and sine of pi over 2 minus x. What are these equal to? Cosine of pi over 2 minus x equals sine x. Sine of pi over 2 minus x equals, why do they call these the cofunction identities? What the heck is a cofunction? Did you guys ever notice there's sine and there's cosine? Did you guys ever notice? Or you just thought they were like two different things, like iguana and monitor lizard? See, pilot and co-pilot. Oh, now I get it. And then tangent and cotangent. Must be they go together somehow, right? And secant and cosecant. Yes, they go together. That's why these are the cofunction identities. What do these identities say right here? If two angles add up to pi over 2 or 90 degrees, then the cosine of one is equal to the sine of the other. That's what this is saying. Okay, look at this angle and this angle right here. Don't they add up to pi over 2? Which is 90 degrees. So when two angles add up to 90 degrees, the cosine of one is equal to the sine of the other. That's what these identities are. So, cosine of 40 degrees, what is that equal to? The sine of 50 degrees. I'm just using degrees now because, I don't know, maybe it's easier for you to understand. And same thing with, so if you have the tangent of 20 degrees, hey, that's the same thing as the cotangent of 70 degrees. Secant of 65 degrees is equal to the cosecant of, wait, Mr. Parker, I gotta borrow. 90 minus 55. 5, we're gonna borrow. 25! When two angles, guys, are you, I don't even know if you're getting this. Guys, just. You guys sure you get that? Why? Why does this work? Okay, let me show you. What did you guys, I'm just curious, what did you guys even learn last year about trig? Just memorize everything and take the quiz. How to Oka? He always tells the truth.
Visualize.
I don't think so. Visualize what? Okay, Okay, stop listening everybody. Okay, would you agree that this angle plus this angle equals 90 degrees? Good. Why is it that the cosine of this is equal to the sine of that? What did we learn last year? What is cosine? Did you guys learn SOHCAHTOA? I don't like to say that because that's like FOIL and all students take calculus, but if you have SOHCAHTOA, okay, what is cosine of alpha? A over adjacent over hypotenuse. What is sine of beta? Wait, so what is the sine then? Opposite over hypotenuse. So what is the sine of angle beta here? Opposite over hypotenuse. Why is A over C equal to A over C? Duh! Okay, let's move on. Okay, so you gotta use now. Okay, anyway. Okay, next we gotta learn how to do proofs. Okay, I just happen to have your Algebra 2 book with me now. Here it is. Because now you can't tell me that you never learned this. Okay, I'm just gonna randomly pick a proof out of this book. Trig proof. Because I think tonight you have 3 to do. Huh? 3 lucky people are going to put it up on the board tomorrow. Okay, where's trigonometry? Trigonometry identities? Oh, we didn't learn that this part. Okay, here. Proof! Let's pick a juicy one. Succulent, tender, good spices. Okay, which one do you want to do? This looks oh! This looks interesting. Here. In fact, somebody circled this one. Cosine x over 1 minus tangent x is plus sine x over 1 minus cotangent x is equal to sine x plus cosine x. Okay, let's prove this. You guys remember anything about proofs? How do you prove that this equation is true? Can I multiply both sides by the least common denominator to get rid of the fractions? Come on, it's a 50-50 shot. Oh. No, you can't! Why can't you? Because we're trying to prove that they're equal. If you start working with it, that means you're assuming they're equal already. How can we prove that they're equal if you assume that they're equal? Watch me, Mr. Park. No, so what did we learn last year? You draw the, what did Mr. Taki used to call it? The iron curtain. Or was that Mr. Rubash? You draw the iron curtain. And what did Mr. Taki used to call it? The line. Draw the line! Okay, so here are the rules. You can work with the left side, you can work with the right side, you can work with both, but you keep working until the left side is the same as the right. Then you can say they're equal. You cannot assume, you understand, you cannot assume they're equal if you're trying to prove that they're equal. Okay, so which side do we want to work with? Usually you work with the more complicated side, yeah? Okay, what did your teacher teach you last year? If you don't know how to do anything, just change everything to sine and cosine. Okay, that you guys heard, right? Okay, so here we go. Change tangent to sine over cosine. Change cotangent to cosine over sine. So basically, all you got to do now is just do algebra, and then I guarantee you, this left side will come out to the right side. Okay, so what do I do? Good. What do you want to do? How do we simplify complex fractions? Multiply top and bottom by the least common denominator. Okay, so this one, multiply top and bottom by cosine x, and you get cosine squared x all over, multiply by cosine x, multiply by cosine x. Okay, this one, multiply top and bottom by sine x, so you get sine squared x all over sine x minus cosine x. So what's the least common denominator now? When you add fractions together, you make the least common denominator. What's the least common denominator? Wait, I just want to call on somebody at random. Zang, what's the least common denominator? Pretend like I know. This times this. No! Yoshina, substitution. What is the least common denominator? Okay, let's go back to arithmetic. What if you had 2/3 plus 1 over -3? What's the least common denominator? 9. -9. No, it's 3. Okay, so go back to this one. What's the least common denominator? Do you notice that this is simply the opposite of this? Well, when you read it like 3, I can see it, but come on, people. We are honors. The H stands for something in PCH, you know. What do you think the H stands for? I knew there was a good answer. Okay, this is the least common denominator. Look what the time is. Oh, we're in trouble already. We in trouble. Okay, so what goes on the top? Cosine squared x minus sine squared x. Right, because you got the negative, right? Now what? Only one more step and we're done. Factor, that's a difference of squares. So you can factor that as cosine x plus sine x. This is just algebra. Oh, this cancels that. And so all that's left with is cosine x plus sine x. Hey! Woo-hoo-hoo. So when the left side and the right side are equal, what? What do you write? Check.
Smiley face.
If anybody writes a smiley face, I'll tell you what's going to happen. Minus 1, 2, 3, 4, 5, 6. Pick up 6 on the spot. I'll tell you what, maybe when you first learn it, you put a smiley face because you guys are like babies, right? You gotta make the baby happy. You don't want the baby to cry. Okay, but now we are doing real mathematics. When you end a proof, what do? You end it with?
QED.
There you go, QED. QED is Latin for Quad Erat Demonstrandum. Who takes Latin here? You guys don't want to admit? I can tell just by looking who takes Latin here. What? Jen? Who takes Latin? Do I have to go down there and look up your schedules?
No one takes that. You did this last time.
Yeah, but I think somebody's lying. Okay, quad erat demonstrandum, which that means that which was to be proven. That ends the proof. So obviously here, nobody looked at the notes I made, because if you look at the notes I made, I did a sample proof, and at the end I put QED. And in fact, did I even explain what QED stands for? Right there, right there. No, I just put QED. But now you know, quad erat demonstrandum. Oh, here, easy to remember, quite easily done. Quite easily done. Okay, we only have 5 minutes left to solve equations. You're in trouble. Okay, let's solve some equations. Now, if you don't know your trig values, you're going to see why you're going to fail the next 3 tests right here. Okay? Anyway, tomorrow's speed quiz. Now, I hope you guys are ready. Okay, let's solve. Solve this equation. 2 sine x equals 1. Divide both sides by 2 sin, so x equals 1 over 2 sin. Box said that's yes. You can't do that! Some of you think, no, I'm serious, some of you think that's sin times x. It's sine of x. They go together. It's just like ln x. That doesn't mean ln times x. It means natural log of x. That's an argument. Oh, now that clears it up. So what should I do to solve this equation? Sine divide by 2, sine x equals 2. Okay, so now you got to know your trig value. Sine of what angle equals 1/2. So this is what should be going on in your head. Where on the unit circle is the y coordinate 1/2? Positive 1/2. There and there, right? This is what you should be thinking. Where is there? Pi over 6 and 5 pi over 6. That's it? No, because this thing goes on forever. You can keep on going, right? So last year, what did we do to show that pi over 6 plus multiples of 2 pi? Because every time you go once around the unit circle, you end up at the same place, right? So how do you say pi over 6 plus or minus any multiple of 2 pi? Because 2 pi is once around the circle, right? Plus 2k pi plus 2k pi, where k is an element of the integers. Does that look familiar? So these are all the solutions. There's an infinite number of solutions. However, I'm going to dumb this down for you. Usually when you solve trig equations, I'm going to just tell you x is going to be between 0 and 2 pi. So I'm just going to restrict it to be between 0 and 2 pi, but you got to know that there's an infinite number of answers now. I'm just restricting it to between 0 and 2 pi because that's what's going to happen when you take the AP exam next year. So what's the answer then if I restrict the domain? Pi over 6 and 5 pi over 6. Those are the answers. Okay, how many examples are we going to get to do here? Okay, let's do another one. 4 cosine squared x equals 3. First step, divide by 4. Second step, square root both sides. Cosine x equals plus or minus root 3 over 2. Hey, you somebody. That's a number I'm supposed to know. So what you should be thinking is, where on the unit circle is the x coordinate plus or minus root 3 over 2? Yeah, this is what you should be thinking, like this. Right? So where is that? A pi over 6 family. Pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. Right? Now you can see, if you don't know your trig values, you are doomed there. You are doomed. You gotta know your trig values. You gotta know your unit circle. Okay, we got 2 minutes left. Oh my goodness. Okay, now there's some problems where you have to actually use the Pythagorean identities to solve it now. Like, okay, but you gotta be able to handle this one. Like, okay, well, let me look at tonight's homework. I don't want to do the exact same problem. Okay, you have a 2x, so I'll do 3x, but watch, you guys gonna do it. We're gonna put it on the board anyway tomorrow. Okay, solve this, between 0 and 2 pi. What do I do? What did your teacher teach you last year? Think of this as theta. Tangent, okay, substitution, but then let's just do it in our head. Tangent of what angle equals 1? That's the, maybe you guys should play this game. Somebody shout out an equation, tangent x equal 1. You just put your arms where it's supposed to be. Sine x equal 1/2. Cosine x equal negative half. Right? Tangent x equal 1. So it's like there, right? So where is there? Look, I did it for you. Pi over 4. 5 pi over 4. However, what did we learn last year? We got less than a minute. If the variable is 3x, what do you have to do? You got to go 3 times around the unit circle. So you can't just stop there. So once you get these two, what you got to do is add 2 pi to both of these. Quick, add 2 pi. I'll give you a hint. 2 pi is 8 pi over 4. 9 pi over 4. 13 pi over 4. But that's only 2 times around. I got to go 1 more time around. Go. Add another 8 pi over 4. 17 pi over 4. 21 pi over 4. Why do we have to do that, Mr. Park? Because now to solve for x, you got to divide by 3. That's why you got to go 3 times around, because you got to divide by 3 at the end. So your answer is going to be each of these divided by 3. So you're going to have actually 6 answers. Okay, looks like we're going to have... Now, believe it or not, we're not learning anything more in this class for this shiggy. That's the end of the lecture. Now you got to get good. Okay, just make sure you're prepared for the speed quiz tomorrow.